Okay, let's take a look at a question like this. So we're looking at this image right here. Choose the graph of the function, and we're given the function f of x equals 2 times 3 to the x power. Obviously, that's an exponential function. It has our right form, right? Where we've got a times r to the x power, where a is our initial value or y-intercept, right? And r is our ratio. So in this case, what is our a, or what is our initial value, or what should our y-intercept be? Well, in the case we're given, right, a is equal to positive 2, right? So we know that the correct graph of the function f of x equals 2 times 3 to the x power is going to have a y-intercept at positive 2, right? Okay, so which of these graphs could possibly represent this function? Okay, well, this first graph here, it looks like it has a y-intercept at positive 1, right? That's not right. What about this second graph? It looks like it has a y-intercept at positive 3. That's not right. Our third graph has a y-intercept at positive 2. So our third graph can only be the correct answer. But let's just double check and let's just make sure to verify that the common ratio of this graph is indeed positive 3, okay? So how can we verify that the common ratio of this graph is indeed positive 3? Well, we know the y-intercept is right. So let's check if the output at x equals 1 is right, okay? Let's plug in x equals 1 into this formula, and let's just make sure the values add up, or not add up, but match, okay? So let's take x equals 1, therefore y, or f of x, should equal 2 times 3 to the first power, right? What's that? That's 2 times 3, right? What's 2 times 3? 6. Okay, well, when x equals 1, what's the value of our function here? Looks right? Looks like it's 6. And that should also make sense, right? Because at x equals 1, that means we're multiplying by our ratio once, right? That means our value should be 2 times 3 once, 2 times 6, right? All right, so this checks out for sure. This is definitely f of x equals 2, not 3, 2 times 3 to the x power, right? That's good. All right, that's too easy, right? This has been too easy. Let's go ahead and actually see if we can figure out the formulas for these other functions, okay? Let's look at this second function here, and let's call it g, okay? We've got f of x, so let's call this g. So what would g of x be? Okay, well, we know for sure that the value of a, or the initial value, or the y-intercept in this case is positive 3, right? So what would b be? What could the value of b be in this case, right? Okay, well, let's look at x equals 1, right? At x equals 1, what's the value of this function? It looks like it's also 3, right? It looks like the value is not 6, but it looks like the value is also 6 for this function, right? Okay, hopefully we remember what we can do from that information. Let me make some room over here to work. All right, here we go. What are we dealing with? We're dealing with g of x, right? We know that for g of x, right? We know that for g of x, a equals 3, right? And what else do we know? We know that at g of 1, the value is 6, right? We know that at g of 1 right here, the output is 6. Okay, so that means at g of 1, we're going to have 3 times b to the first power, right? And that's going to equal 6, right? Because, of course, this is an exponential function, so it's of the form a times b to the x power, right? That's g of x. And what's g of 1 in terms of the formula? That's a times b to the first power, right? And we know that a is equal to positive 3, so this becomes 3 times b to the first power. And we know from the graph that this is also equal to 6. So 3 times b to the first power is equal to positive 6. We can divide both sides by 3, right, to get b by itself. B to the first power is equal to 2, which means b to the first power is just b, right? So this means b is equal to 2, all right? So for this exponential function, a is equal to positive 3, b is equal to positive 2, so we can say that g of x is equal to 3 times 2. to the x power, right? All right, this isn't so hard to do, is it? Okay, let's make some room over here so that we can work on our first graph here. So we can work on our first graph, okay? You know what would be really boilerplate and stereotypical if I went ahead and called this first graph h of x? I'm not. I'm going to call it j. We're going to call this j of x to be a little interesting, okay? So what do we know about j of x? Well, we know that j, let's make some room here. We know that, not an uppercase j, a lowercase j of x has to be a times b to the x power. It has to be an exponential function. It is an exponential function. What does its value of a have to be? Well, let's look at its y-intercept. Its y-intercept is at positive 1, so a is value positive 1, right? Okay, so how can we find the value of b? How do we find the value of b, the ratio of j of x? Well, let's think of it this way, right? At j of 1, right, at x equals 1, that means we will have multiplied our initial value by the common ratio once, right? Because that's what these functions mean. That's what the input means, right? How many times are you multiplying your initial value by the ratio, right? So what is the value at x equals 1? Looks like the value is 3, right? It looks like that the value at x equals 1 is y equals 3, right? So if we start at our initial value 1 and multiply by the common ratio just one time, our value is positive 3. Well, 1 times what gets you to positive 3? Positive 3, right? So it looks like b must be positive 3. So therefore, it looks like j of x must equal 1 times 3 to the x power. When we have a coefficient of 1, we often just don't write that coefficient, right? So it looks like j of x is simply 3 to the x power. Let's pick a point and sort of test that out, right? Let's try to pick a point and test that out. Like x equals 2. Let's pick x equals 2 here. Go up from x equals 2, see where we hit the function. Gonna hit it right here. It's kind of hard to tell, right, because the line isn't very thin, but we're gonna hit it right there, and that corresponding y value is positive 9. So we know that j of 2 should be equal to positive 9, right? Well, if we plug in x equals 2 to our formula for j, right? Or, yeah, j, do we get positive 9? Well, if j to the x power, if j of x is 3 to the x power, j of 2 should be 3 to the second power, 3 squared, which is positive 9, right? So we can say that this first graph is simply 3 to the x power, right? And there we go. We can always go from our formula or equation to a graph. And if we have a sufficiently detailed graph where we can match up the inputs and the corresponding outputs with some certainty, and if we can be able to spot the y-intercept, we can also look at a graph and tell you what the equation of that exponential function is.